Determine the magnitude of the projection of force F equals 600 Newton along the u-axis. Okay, so that's the u-axis. So determine the magnitude of the projection of force F equals 600 Newton. That's along the u-axis. So we have an applied force here of 600 Newton, and the question is asking from us to determine the magnitude of the projection. So we need to project this force onto the u-axis. Okay, so let's write down some unit vectors. Unit vectors. So we need to determine a unit vector OA such that we can write a F vector as a Cartesian vector, and then we need to write a unit vector along axis U with respect to using the coordinate axis system here, x, y, z. So for the force F equals 600 Newton, the unit vector unit vector OA, so a unit vector directed along OA, so from O to A. So we can write this unit vector by using position vector ROA, and that will be divided by the length of the position vector or magnitude of that vector. So the position vector can be written as the coordinates of we consider coordinates of A and coordinates of O. So the coordinates of A, note here that the coordinates of A is -2 for X and 4 for Y. So it's 4 and then -2, 4, and then 4 for Z. And here the coordinates of point O is 0, 0, and 0. Okay, so it's quite straightforward actually. So that's I plus 4 minus 0 J and plus 4 minus 0 K over square root of these values. So we're going to be having -2 minus 0 is -2 squared, -2 squared, plus 4 minus 0 is 4, 4 squared, plus 4 minus 0 is 4, 4 squared. So we end up with unit vector OA as -1/3I plus 2/3J plus 2/3K. So this expression is 3. Okay. So for the u-axis, we have a unit vector UU, and that is I, J, K coordinates can be written by using the angles. So we have an angle, so the u-axis is having an angle of 30 degrees with y-axis. Okay, so we're going to be having like sine 30 for the x component and cosine 30 for the y component, and that's 0 for the z component. So we can use the angles to write the unit vector. So for UU we have sine 30 I plus cosine 30 J. Okay, so the force vector will be, so we can now write the force vector as a Cartesian vector. The magnitude of the force vector times UOA, the unit vector, and that will be 600 times minus 1 over 3I plus 2 over 3J and plus 2 over 3K, and that is equal to minus 200 I plus 400 J and plus 400 K, and that's Newton, yes? So the projection of a vector along the specific axis is found by vector dot product. So vector dot product is used to find the projection of a vector onto an axis. So the magnitude of the projected component of F vector which we just found. So the projection of this vector, but obviously we're asking for the magnitude of that projected component. F vector along the u-axis. That will be Fu vector will be equal to F times, that's the dot product, UU vector. So from there we can continue writing the equation. So that will be 200 I plus 400, so that's the force vector, J, that's the dot product, J and plus 400K, and then dot product, sine 30I plus cosine 30J. Okay. So remembering how to multiply, how to calculate the dot product of two vectors, we're gonna find that to be minus 200 times sine 30 degree and plus 400 times cosine 30 degree and plus 400 times 0. So let's just remember, so we have vector A dot product vector B will be equal to AX times BX plus AY times BY plus AZ times BZ. So these two vectors are expressed as Cartesian vectors. So A is equal to AXI plus AYJ plus AZK, and vector B is expressed similarly, BXI plus BYJ plus BZK. So this is how we find the value of the dot product of two vectors. So this was a side note just for us to remember. So this is recall recall that dot product is found in this way. Okay, so this calculation leads to Fu will be 246 newtons. And that's the answer. And this concludes the solution of our problem. Thank you.